name's Tristan and I live in Amsterdam. I do freestyle BMX. In this sport, balance is super important. This, for instance, is grinding, gliding on a bar attached to your bike. And this trick is called the rocketeer. Jump in the air with both feet loose. It's really difficult to keep your balance. Today's foolproof is about balance. Balance is also important when just riding your bike. I learned to ride when I was 4. I don't just do tricks, I also use my bike to go to school. Even when it rains. Then I wear this great looking rain suit. And this is Johan, my strong friend. Okay, that's enough, thank you. Time to do the first balance experiment. The first experiment. How to divide a baguette into 2 exactly equal parts without using a ruler. First, I try to estimate with my eyes. Let's see what the middle is. No, the parts are not exactly equal. Too bad. So, can we use balance? Yes. I place the baguette on 2 fingers and slowly move them towards each other. You may not believe it, but this actually works. The place where my fingers touch is the middle, if I'm right. Yes, look, exactly right. The center of gravity of the baguette is in the middle. One side is exactly as heavy as the other side. The baguette is not the only thing with a center of gravity. Everything has one. A cucumber, and even John's super heavy weights. I have a center of gravity too. My head and my body weigh exactly the same as my legs. The center of gravity is somewhere in my belly. Staying balanced is not just about the center of gravity. Another important thing is the supporting surface. What is that? Experiment number 2. I roll up the black exercise book really tight, and then I roll up the red exercise book really loose. Done. Which will fall over first, the black or the red exercise book? Come on, Johan, you can lift it. First, the black, tightly rolled up exercise book falls over, and then the red. But why does the black book fall over sooner than the red one? The black one rests on a really small surface. The red one rests on a broader surface, so that one has a bigger supporting surface. The center of gravity is in the middle. An exercise book falls over when the center of gravity is no longer above the supporting surface. That happens sooner with the black one with the small supporting surface. And then the red one goes. If I spread my legs, I have a broad supporting surface. As long as my center of gravity is above the supporting surface, I don't fall over. With a broad supporting surface, you're very stable, super stable, mega stable, like a house. You also often see a broad supporting surface in buildings. Pyramids were built thousands of years ago, and they're still standing. And the Eiffel Tower is really a tower with its legs spread. And this church has so-called buttresses on the outside. They keep the building from falling over. They should have done the same for this tower. Back to the bike. If you look at a bike from the front, the supporting surface is very small. It stays upright when the centre of gravity is above the supporting surface. That doesn't work with such a small supporting surface, but it can be done. You need to broaden the supporting surface of the bike. Guess how I do that? By using training wheels. Experiment number 3. How do you balance an apple on this really small supporting surface? Well, this doesn't work. Watch what happens when I stick 2 forks into the apple. Ta-da! The weight of the forks bring the centre of gravity down. That way, the apple can balance on a small edge. Cool! So, moving the centre of gravity is a really handy trick to keep your balance. When you see a cat, you would think it always walks with its tail in the air to keep its balance. But on a small edge, it will bring its tail down to keep its balance. Experiment number 4. How do you make a soda can stand on its edge? Not like this, because the centre of gravity is not above the supporting surface. And yet, it can be done. Almost empty the soda can. The centre of gravity will be moved down. Now it can stand on its edge. And now it's time for a big and dangerous experiment. Do not try this at home. What you can do with apples and soda cans, you can also do with bikes. I hang some extra weight underneath the bike. Ta-da! I've lowered the centre of gravity. So, now I can stand on this really small edge. The centre of gravity of a broom is here. The 2 pieces are not equally long, yet the brush with the short stick is in balance with the long stick. A crane makes clever use of that. On the short end hangs a heavy weight. It's in balance with the long end. With the long end, you can lift things and move them to places that are difficult to reach. This is fun too. 115 kilos on the short end is in balance with 35 kilos on the long end. I don't need a crane to lift something, just a long stick. This car weighs 1,000 kilos. Isn't that cool? Experiment number 7. Time for a little match. We take a broom and a pencil. We place them both straight up. What is easier to push down flat on the floor? 3, 2, 1. Yes, I won. Not so strange, for the centre of gravity of the broom is really high, and the higher the centre of gravity, the longer it takes before it's flat on the floor. Round 2. What is easier to balance on your hand? You may think it's the pencil, but it's not. A broom will less easily fall over, which gives me time to move my hand. With my hand, I bring the supporting surface underneath the centre of gravity. A pencil falls over so quickly, you don't have time to do that. The same thing as with the broom happens when you're standing on one leg. You shift the supporting surface to keep from falling over. A little yogurt will show you what I mean. If I stand in it on one leg, you can see my foot move. I shift my supporting surface from one place to the next to keep it underneath my centre of gravity. When you're riding a bike, you also need to keep your balance. Luckily, a bike has handlebars. By moving the handlebars, you can bring the centre of gravity back above the supporting surface. It's difficult to see, but when I exaggerate, it looks like this. I lose my balance when the centre of gravity is no longer above the supporting surface. By moving the handlebars, I bring the centre of gravity back above the supporting surface, and I can stay straight up. Quite difficult, you know, riding a bike. Experiment number 8. If your wheels are in the trem rails, you can no longer move the handlebars. So, can you still ride your bike? Let's give it a try. No, that doesn't work. But here's the beauty of it. You have to learn how to ride a bike, but you don't have to teach a bike anything. It can ride even without me on it. If I give my bike a push, it stays upright, all on its own. The handlebars keep the bike straight up. Handy to have a bike that steers itself. All I have to do is sit on it. The bike does the rest. Can't wait to see where my bike will take me.